Hi everybody, just me here hanging out in my classroom by myself, teaching all of you at home. So today we're going to learn 3-step stoichiometry, and if you missed last week, meaning you didn't learn how to do 1-step or 2-step, I have linked that video on Canvas as well. So please watch that video and do those notes first, because once you understand 1-step, 2-step, 3-step is just one more. But if you try to start with 3-step, it could be a little bit overwhelming at first. For those of you that were here for 1-step, 2-step, I've also posted the answer key to the homework assignment. So I would encourage you to please click on that link and make sure that you are doing it correctly, so that if there are mistakes, we can fix them before we jump into the 3-step. Okay, but if you're good on all those, then let's learn how to do 3-step. So we are on page 3 of your notes. You should have a yellow note packet from last week. If you weren't here last week, I've also posted a link on the website where you could print this off and then fill those in. And we're starting on page 3 with the first problem. Okay, so the problem says how many grams of copper are required to react with 0.10 grams of silver nitrate. So the first thing, just like last time that we mentioned, is you should identify what you know, like what's the information that's given, and then what is the information that you're trying to find. In the problem, we're going to underline what we know. So I'm going to take your pencil and underline 0.10 grams of silver nitrate. And then we're going to circle what we're trying to find. So everybody circle grams of copper. Now notice that I didn't just say circle grams, because one of the things with 3-step stoichiometry is that we're changing between substances. And so you need to know what substance, not just the unit. So the unit is grams, but grams of copper is what we're trying to find. Okay? Then the next step, after we've identified what we know and what we're trying to find, is go to the map and figure out how we're going to get there. Okay? So we have grams of one thing, so we're going to be starting on the known side. Okay? So this is our start box, because this is grams. And then our end box is grams of something new. So we're going to try to end over here. So I'm starting here, ending there. Remember, there are no airplanes to travel. So we have to go 1, 2, 3 steps. And like we said, that's how all the problems are going to be today. Okay, so once you've identified your pathway, let's go ahead and build our road of conversions. So take your 0.10 grams of silver nitrate, and you write that first. Okay, so the thing you have underlined is the thing that you're going to start with. I'm going to write the balanced equation. It's on your paper, but it's not on mine. Now, some people might have been asking, how did I know that silver nitrate was AgNO3? And that goes back to our naming unit. But you also kind of have the shortcut of it's something in here. And so the one that has silver and nitrate together is that formula. Okay? All right, so first step. We're going to take grams of silver nitrate. Now let me split our map here. So this whole side of the map is for silver nitrate, because that's what I know. And that whole side of the map is for copper. Okay? So our first step is we're going to go from grams of silver nitrate to moles of silver nitrate. So, diagonal pattern, so grams of silver nitrate go on the bottom. I'm going to change colors here on purpose, because I'm changing it into moles of silver nitrate. Now notice once again, I don't have any numbers plugged in. I think it's best to set up the pathway and then worry about the conversion numbers. Okay, all right, so let's keep going. So next step, I'm traveling from moles of silver nitrate, and I'm going to moles of copper. So here's my step 2. Okay, diagonal pattern. So wherever you're leaving goes on the bottom. So once again, notice the color. Mole of silver nitrate. And I'm changing that into, let's get a new color here, moles of copper. Okay, so there's step 2. And step 3, we're going to go from moles of copper into grams of copper. So diagonal pattern, moles of copper, and then I'm changing it into grams of copper. Okay, now we have our setup. So once you have all your setup and the road is built correctly, then we can worry about what to plug in. Now, when we plug something into this fraction, it's the thing that connects these two pieces of the puzzle, which is the same from the last unit and also what we learned last time as well. So the thing that connects grams of a substance to moles of that substance is the molar mass of it. And you should have that filled in from your notes prior. Okay, so the molar mass of silver nitrate is what we need to find here. Now, molar mass is where we take all the individual components and add them together. So we'll take the mass of silver, the mass of nitrogen, and the mass of 3 oxygens, add them up. When we do so, we get 169.87 for every 1 silver nitrate. Okay? All right, this conversion is comparing moles of something to moles of something else. The thing that connects substances together through the mole is the balanced equation. So we're going to go to the balanced equation, and I'm going to say, all right, so for copper, there's nothing there, so that means there's 1 of those. For silver nitrate, we have 2 of them. So this step right here was the balanced equation. Okay? All right, final step is comparing moles to grams again. Notice it's a similar relationship here. We are comparing moles to grams, so once again, it's just molar mass. Molar mass of copper, when I look at the periodic table, is 63.55. Now notice this time, because the gram unit is on top, that's where it goes, because there are 63.55 grams in 1 mole of copper. Okay, if you plugged it in the other way, you'd be saying that there's 63.55 moles for every 1 gram, which doesn't make sense. Okay, plug that into your calculator. The way I would plug this in, so here's my calculator. This is what I would plug in, is I would hit 0.10, divide by 169.87. So anything that's the number 1, I just don't type in my calculator because it does nothing. Anything that's on the bottom, I hit divide. Anything on the top, I hit multiply. So that's my preferred method for plugging it in. And when I did so, and after rounding, I got 0.02 grams of copper. That's my final answer. Okay. All right. Also note, there is a discussion board link to this video. So if after watching the video you have a question about one of these things, please post, and then I will get back to you to help you out with your questions. All right, let's try the next problem. Okay, so same thing again. Let's read the question and identify what we're trying to find and what we already know, so we can build our map to get us there. So let's get some smiley faces from home. So take a moment and circle what you're trying to find and underline what you know. All right, if you have circled grams of KClO3, you can have 1 smiley face. And if you have underlined 2.7 times 10 to the 24 oxygen molecules, you can have a 2nd smiley face. Okay? All right, so now this time with our map, we split it again. So the 2 things we're comparing is we're comparing oxygen to KClO3. Let's get our balanced equation up there again. All right, so I'm starting with molecules, which falls into the particles box of oxygen, and I'm trying to get to grams of my KClO3. Okay, so my 1, 2, 3 steps. Okay, all right, so take what you know and write that first. So we're gonna write 2.7 times 10 to the 24 molecules of O2. Okay, step 1 is to change molecules of O2 into moles of O2. Okay, so diagonal pattern, molecules to moles. Okay, so there's our step 1. Step 2, we're going to change from moles of O2 into moles of KClO3. So moles of O2 into moles of KClO3. Step 2. And step 3, we're now going to go from moles of KClO3 and change it into grams of KClO3. And there's our setup, okay? So we're going from molecules to moles, moles to moles, moles to grams. Okay, let's plug in our conversion factors. So the thing that connects molecules of a substance to moles of a substance, the thing that relates those two is Avogadro's number. Just kidding, Avogadro's number. So Avogadro's number is 6.02 times 10 to the 23rd, and that's how many molecules are in 1 mole. So that's why it goes on the bottom, because there's that many molecules per mole of oxygen. Okay, the thing that connects moles to moles of a substance is the balanced equation. So we have 3 of those for oxygen and 2 for KClO3. And then the thing that connects moles to grams of a substance is the molar mass, which for KClO3 I got as 122.55 over 1. Okay, plug that into your calculator, and if you plugged it in correctly, you should get 373.21 grams of KClO3. Now, I would encourage you to pause the video and once again practice typing this in to make sure that you're typing it in correctly. One of the biggest mistakes to remember is with Avogadro's number, okay, you have to put the entire thing inside of parentheses when you use it, or you can use the calculator shortcut, and that one doesn't need parentheses. But if you don't do this or you don't do that, you're going to get it wrong just because of your calculator, not because you actually did it wrong. So, okay. All right, for the third problem, what I'd like you to do is if you're feeling confident, go ahead and pause the video and try it on your own. And then afterwards you can play and make sure you're doing it correctly, okay? Okay, so here is the setup, the steps, and the answer for number 3. So take a moment. If you got this answer right, great job, that means you're on the right track. If you didn't get the answer right, then take a look at your work, take a look at my work, and let's identify what went wrong, right? It's fine to make mistakes right now. We're still just learning, we're still just practicing, but we want to learn from our mistakes so we don't keep making the same mistakes again. Now, once again, if you have questions, like you don't know why you got it wrong, post on that discussion board and I can help you out. If you feel like you've got it at this point, then go ahead and you can Your homework for today is to do the 3-step worksheet in your packet. And then after completing the 3-step worksheet, you'll go onto Canvas to plug that in. Plugging it in should do 2 things for you. Number 1, it's how you're going to get credit for the assignment. Number 2, more importantly, it will help you know that you're doing it correct or not. You have 3 attempts at it, so if you get it wrong, you can relook over it and try again. There's also a discussion board, so you can post questions that you have about the assignment. So if you're like, hey, I'm stuck on number 6, I can't get it right, you can go ahead and post about it, and then I'll get back to you on how to help you. With that assignment, make sure though to actually cross off number 5. Okay, number 5 got put on there from another year, but it doesn't apply with what we're learning right now. So cross off number 5, you don't need to do it, you won't have to plug it in. So, and that is 3-step stoichiometry. So good luck, everybody. Once again, don't be afraid to reach out with questions that you have. The assignment will be due on Friday, and then we will have our next lesson. Okay, see you then. Bye.